Next up in our crash course is the rationals unit. So rationals unit, we can do a couple things. First thing, if it says sketch the graph of the function, let's see if I can get myself a grid to work with. Sketch the graph. I'm going to analyze this. I need to find the zeros and the asymptotes. So first thing, if I set the numerator equal to 0, then that means that x equals 2. That's an x-intercept at 2, 0. So I can put a dot right there. So first thing, I can find an x-intercept. I can find vertical asymptotes by setting the denominator equal to 0. That'd be x equals -4, so I can draw 1, 2, 3, 4, a vertical line. That's an asymptote, so I'll make it dashed. What else do I need here? I could find the horizontal asymptote by dividing the coefficients. So since they have the same degree, you divide the leading coefficients, and 1 divided by 1 is 1. So now I have a horizontal asymptote, y equals 1. And then I can use my sort of common sense here to figure out how this thing's going to look. Let's take, if it's going to go out forever and it's going to get to this and it's going to go down like this, and I know that these are always going to look like that unless there's something squared. So I can check that in my calculator by going in here and saying x minus 2 divided by x plus 4. On your final exam you're going to have your calculator, so you might as well, hang on, zoom, standard, verify your answers and make sure that this looks pretty much like that. So I'm feeling pretty good about that graph. You do need to be able to analyze it though. Numerator, denominator, and then how to find horizontal asymptotes. What if it says solve? So most of the time you're solving equations, it's a good idea to get a common denominator. Sometimes you want everything in the problem to have a common denominator. This problem, I can get a common denominator for everything in the problem without too much work. This guy has an x plus 6, this guy has an x. So all he needs is an x. And when you do that, you have to do it in the numerator and denominator. This guy is going to need an x plus 6 in the numerator and denominator. So x plus 6, and then this guy needs an x. Now, you're going to have to FOIL in this middle one, x plus 1 times x plus 6. So I'm going to write this on the left side as my new single fraction with denominator x, x and x plus 6, and then over here I have x plus 6. I know my numerator up here is 13x. This is x plus, and then when you FOIL, you're going to get x squared plus 6x plus 1x plus 6. Now the cool thing about doing it this way is now that you have x times x plus 6 as the denominator on both sides, you could clear the fraction by multiplying both sides by x plus 6. So now it's gone. And now all I need to worry about is over here, I can combine some like terms. I have x squared plus 6, 7, 8x plus 6 equals, on the right side, I have 13x. When you see it's a quadratic, you need to get everything on one side. X squared minus 5x plus 6. And hey, look at that. It's a quadratic that I can factor. I can do split the middle. And when you do split the middle, you're going to get x minus 3, x minus 2. I'm not really showing my steps there. I'm doing that in my head. So x either equals 3 or x equals 2. The important thing about solving rationals, though, is that you go back and you check to make sure these are not extraneous solutions. And what that means is, if I plug in 3, will it try and divide by 0? 3, no, okay, I'm fine. If I plug in 2, will I divide by 0? Nope, I'm okay. So I can plug in 3, I can plug in 2. That means these are both solutions to my equation. Let's do another one. Same kind of thing here. I could get a common denominator, but in this problem, since there's no like terms, like I don't need to combine any fractions, I can just cross multiply this one. So I'm going to do 2 times x plus 1 and 3 times x minus 4. And now that I've got this fraction, I can distribute, got rid of the fraction, I can distribute 2x plus 2 equals 3x minus 12. I can get all my x's on one side, so you subtract 2x. And then I can add 12, and I get 14 equals x. And as long as that doesn't divide by 0, which it doesn't, that'd be 15 and 10, good, then you know you did it right. Last thing you need to be able to do is simplify rational expressions. I might give you some of these complex fractions. I might give you something to factor. Here, you're going to need to factor. And I'm not going to show all my split the middle steps, but I'll do one of them. I'll split the middle. So I'm going to take the first one and just remind you how to split the middle, but the other ones I'm not going to show my work. So I'll take this one down here and say, okay, I'm going to factor this. If you're going to factor a trinomial, you need to multiply the first term and the last term. That's 6 times -2, that's -12. So I need two numbers that multiply to -12 and add to the middle coefficient. That would be +1. So the two numbers that multiply to negative 12 and add to 1 are going to go in the middle. So what numbers do that? That would be, let's see, multiply to negative 12 and add to 1. How about positive 4x and negative 3x? Those multiply to negative 12 and they add to 1. Now we're going to do grouping. So I'm going to find the GCF of each of these two portions of my problem. 6x squared plus 4x, the GCF is 2x, and I'm left with, whoa, what happened there? Whatever. 3x plus 2, and then the GCF on the right side, that's a negative sign, so you bring that down, the GCF is just 1. So if I bring out a negative 1, I have 3x plus 2, and now that factored is 2x minus 1, 3x plus 2. So now that I have this guy factored, I'm just going to bring this up here and say, all right, I got the numerator factored for the first part. I'm going to factor all these other ones, and I'm going to do it kind of in my head. Okay, so let's see. This is 2x. This is x, and I need to be 9, so let's do 8 and 1. 8 and 1 makes 9. Down here, I'm going to need to factor this one, so 3x and 2x. Let's see, I need it to be 7, so let's make this 1 and 6, that's 7. 2x, 1x, 8. I got to have a negative here, so 8 minus 1, there we go. So I didn't show any of my work, I'm just factoring these. Now let's see if anything cancels. 2x minus 1 cancels, 2x plus 1 cancels, 3x plus 2, no, that doesn't cancel. X plus 4 cancels though. This should be a 2, I think. 3x squared, yeah, that should be a 2. 6x squared plus 3x plus 4x, there we go. This needs to multiply by 2. So that is a 2. That means that does cancel, which means everything cancels. This whole thing cancels out to 1, which is kind of silly, but sometimes it works out that way. Just make sure that you take your time and you split the middle correctly for each one of those. Last thing, complex fraction, I need to get a common denominator, so I'm just going to focus on the numerator right now, and we'll get a common denominator here. This guy needs to be over x, but you can't just do it in the denominator. You have to do it in both the numerator and denominator. So now I have 15x minus 2 over x. That is my numerator. That's still being divided by my denominator, which I'll work out over here, x over 5 plus 4. This needs to be over 5, so I got to do it on the top and bottom. That would be x over 5 plus 20 over 5. So my denominator is x plus 20 over 5. Now that I've got it set up, I can rewrite this, and 15x minus 2 over x. I can copy the numerator, change to multiplication, and flip it. And I don't know if anything really goes away. Nothing really cancels. This is a minus sign, to be clear. So I guess what I'll do is distribute. 5 times 15 is 75x minus 10 over x squared plus 20x. You have to distribute on the top and bottom. So my final answer is 75x minus 10 over x squared plus 20x. And that's it for rational.